Okay, now about statistics, and today's discussion is about mode. Mode is an example of measure of central tendency. Mode is the most frequently occurring set value in a data, and there may be no, in some data, there may be no mode, or maybe have several mode. So let us see mode. Mode is really comprehensive and easy to calculate. It is not affected by extreme values of data. Mode can be conveniently located even if the frequency distribution has class intervals of unequal magnitude. Open-end classes are also do not pose any problem in the location of mode. Mode is the average to be used to find the ideal size. So the disadvantages of mode is that it is ill-defined. It is not based upon all the observation. It is not capable of further mathematical treatment. As compared with mean, mode is affected to a great extent by fluctuation of a sampling. So let us see some examples of mode. We can see a mode with a raw data, 10.3, 4.9, 8.9, 11.7, 6.3, and 7.7. That one, there's nothing which is recurring, which is common. So all of the numbers are recurring at once, so there's nothing which is common. Now, in data set number 2, you have 63, 49, 89, 63, 49, 49. You can see that 49 is appearing 3 times, means that it is the one which is appearing several times. That means 49.9. 4.9 is the mode. Then we have the round set of data 21, 28, 28, 41, 43, 43. You will realize that in this set of data, 28 and 43 is appearing twice. So in this case, we say that this set of data has 2 types of mode. Then we have mode for ungrouped data. Like for example, 2, 2, 3, 4, 6, 7, 4, 4, 4, 4, 8, 9, 0. You can see that 4 is appearing 5 times, so that is the mode. Then 10 in the second data is that 10 is appearing twice and 3 is appearing twice. That means in that set of data, the mode is 10 and 3 because they are appearing twice and equally the same. So set data number 3, all numbers are appearing at once, meaning that this type of data has no mode. Now, let us see the formula of calculating a mode in ungrouped data. In ungrouped data, the mode is, you classify, first of all, you have to classify the data. And if you have put the data in class, the mode is the raw limit of the mode class plus the mode frequency minus frequency of just class below the mode divided by 2 frequency mode minus frequency just before the class minus frequency after the mode, then multiplying by the class difference. Class difference, that is the mode of that one. In this case, you can see that FM is a mode frequency. F1 is a frequency just below the mode class, and F2 is frequency after the mode. L1 is lower limit of the mode class, and C is the class difference. What do I mean when you talk of that? Now, let us see this data so that you see whether you can be able to calculate this data. Now, we have a group data of classes. We have 1, 2, 3, 4, 5 classes, and the class has a length of 10. The first class is 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. And you can see the frequency there. So after you put that classes, you'll see that the The age group of 20 to 30 is as a frequency of 3. 30 to 40 as a frequency of 20. And 40 to 50 as a frequency of 27. 50 to 60 as a frequency of 15. And 60 to 70 as a frequency of 9. So in this case, let us look at the frequency, or let us look at the mode. In this case, we have classified the data in that way. So, so if the number is how many you want the number of persons, then you look at what point does that mode occur. Now, in this case, you realize that the mode, the most frequency is a class of 40 to 50. 40 to 50, that is here so many people are. That means that is here the mode of is lies between that one. At 27, because it's one occurring most. So that means in a class of 40 to 50, that is here the number which is occurring most is common. In that now, we have to put the formula there. What is F1? The frequency just before the mode frequency, which is 20. The lower limit of the class is 40, and the upper limit is 50. The frequency mode is 27, and the frequency mode after the class with the mode is 15. And the class length is 40, 50 minus 40. That is the class length. Now, if you have that one, then you put them on the formula where you say that mode is equal to lower class plus frequency mode minus frequency before the class of before the class with the mode, then divided by frequency of the mode times 2 minus frequency of the class before the mode minus the frequency after the class. So up there we have seen those ones. So we have seen the mode is what the mode is, the raw class is 40, and the frequency mode is 27 minus the frequency before the class is 20, then divided by the frequency of the mode is 27 and the frequency of class before the mode is 20, then the frequency after the mode is 15. So after you do that mathematics times 10, which is the mode difference. So after that one, you do the mathematics, you get 43.68. And that is the formula of calculating the mode. So in this case, you have to do another calculations of the mode, like this one here. Here you see IQH and the frequency. In this case, what is the most common? The most common is 43 frequency. The highest frequency is 43, and that means the mode lies in the class of 130 to 140. So the most common here now, you have to put those figures there. You have to say that the most common is in the class of 130, 140. So if you see the class length is 140 minus 130, which is 10. Then the lower limit is 140, the upper limit is 140. The 130, lower limit, the upper limit is 140. Then the class before the mean mode is 38. The frequency in the mode is 43, and the frequency after the mode is 28. So after that one, you put up your formula like that one, where you say that lower limit frequency of the mode minus frequency of the mode before the class divided by frequency of the mode minus frequency of the class before the mode minus the frequency after the mode minus from the 2 times 2 of the frequency times the length of the class. And in that case, now you get 130.6 as the mode. So the key thing here is that you should be able to master the formula. You should be able to arrange your data, and then you'll be able to understand those ones. So relationship between mean, median, and mode is that mode is equal to 3 median minus 2 mean. And so the summary of central tendency measures is that mean is balanced point, median is the median value of one order, and the mode is the most frequency. And I think that is the end of today's topic about the most common, that is the mode. And you have seen the formulas. Thank you very much.